Welcome to ANT 303, Modernizing Log Analytics with the Amazon Elasticsearch Service. My name is Kevin Fallis. I'm a Principal Specialist Solutions Architect with Amazon Web Services. And today joining me on stage is going to be Seth Carroll and Kumar Anand from the Capital One Auto Finance Group. First of all, we're going to dig in a little bit on the Amazon Elasticsearch Service to give you a high-level overview and then discuss some of the features and innovative activities our development team has been building for you. The Amazon Elasticsearch Service is a fully managed service. It enables you to deploy and operate Elasticsearch clusters at scale. It deploys Kibana with the managed service, and it gives you the capabilities to apply industry-leading reliability, scalability, and security. The capabilities of the Amazon Elasticsearch Service is that it's fully managed. And what this means is that the service will deploy all of your instances that you choose in the region that you choose, and that comes down to the storage and the EC2 instances and all the other software that's associated with the Elasticsearch and Kibana offering. You're also given direct access to the Elasticsearch APIs, and this is important for customers that are looking to maybe leverage their existing infrastructure that is already wired in for Elasticsearch. Next, it's cost effective, and there are no licensing fees for the features that are available to you. And we'll discuss a little bit more about what those features are here in a few of these slides. It's designed for zero downtime, and you can scale without interruption. And what this means, if you make changes to your cluster, you're going to seamlessly be able to make those changes and still send requests and interact with the Elasticsearch instances. Finally, it's secure and compliant. From the compliancy side, we offer HIPAA eligibility, PCI DSS compliances, SOC 1, 2, and 3 certification, FedRAMP High and Medium, medium in most of the United States, and FedRAMP High in the United States GovCloud regions on the East and West Coasts. Additionally, there's many ISO compliances that are offered from ISO 9001 to 27001. If you want to, go ahead and navigate to our compliance website at AWS, and you can look at all the details that are associated with our service. So some of the important features for modernizing log analytics have been developed over here probably the past year. Last year at reInvent, we did introduce UltraWarm, and I will talk about that. But a couple things that I want to highlight that I think are meaningful are the following. First of all, we introduced cross-cluster search here probably a couple months ago. And what this allows you to do is to separate your workloads and isolate workloads when typically you might have run multiple workloads on a single Elasticsearch cluster. And for many of those that have done this before, some applications are a little bit chattier than others when it comes to log analytics. And sometimes you need to tune those independent workloads based on your needs for log analytics. So with this solution, you can use a single pane of glass to effectively view your data across multiple clusters when it comes to the Amazon Elasticsearch service. The next thing I want to talk about, which is probably one of my favorite ones, and I'm really excited about this because many customers have been asking about this, is custom domain names and direct SAML integration. Now, in the past, you would have had to use Cognito for SAML integration, and also you might have wanted to bring your own certificates to the Amazon Web Services, Amazon Elasticsearch service. So what we've done is we've offered a custom domain name and SAML integration, and really what this comprises is with your existing deployment, you're going to go ahead and configure a DNS name, and I usually use a subdomain. For example, I might use es.aws.example.com. But anyway, you define that domain name, and you go ahead and you create a cert. Now you can use the ACM or the AWS Certificate Manager to do this, and it's a really nice, clean installation activity. But once you have your certificates available, what you're going to do is you're going to install that on the Amazon Elasticsearch service, and you're going to find that friendly name. So once you define that friendly name, then you can access that using a common domain name that is sympathetic to your company's image or its vision on how you want to expose names to customers. Next, when it comes to the SAML integration part, what you would do is enable SAML integration on the Amazon Elasticsearch service. And once you've done that, you're going to go ahead and integrate with your identity provider. So there's a multitude of identity providers out there. Any of them that support a SAML protocol will be eligible to interact with our service. So once you've configured the provider up and you've gotten all the details married together, then you can go ahead and install that SAML IDP metadata to the service, at which point in time, once things are fully deployed, you will be able to interact with your favorite identity provider through browser redirects, and then you will be able to see a nice SAML integration, a single sign-on, and the ability to have your own beautiful, pretty DNS names. So, what will happen then is that your developers and your users can then access Kibana through the single sign-on URL, and they will then be redirected through Kibana through all of the normal activities with the service. Next I want to talk about is UltraWarm for Amazon ES. And what UltraWarm allows you to do is to take your long-term retention data, and let's say you want to retain for 180 days or longer. What you can do is you can move it into this lower cost storage tier. It's backed by S3, it's highly durable, and it's very cost effective. And some customers can get up to 90% cost reduction on these long-term retention policies that they might set for their data for their company. So the final thing I wanted to mention, when it comes to the UltraWarm and the movement of data is the introduction of the index state management plugin. Now, the Amazon Elasticsearch service draws from the open distro and the open source ecosystem when it comes to plugins. And when we look at plugins, we want to make sure that we're giving customers full functionality. Now, with the index state management plugin, what you're able to do is define policies for your data. So effectively, it works the following way. You send your data to the Amazon Elasticsearch service, and you define a policy in index state management. And then, this is going to land up in the hot tier. Now, when your data goes past a certain retention period, then you can use a policy in the index state management plugin to move that to the tiering, or, when you're finally done with that data, go ahead and delete that data all through a single policy that's controlled at a single point of entry on the Amazon Elasticsearch service. And this is beneficial for customers because you don't have to leverage things like Lambda and Curator and bring those, external activities together. It's all going to be done in one place. And so many customers find this very helpful. Now, the final thing I want to talk about, which is really important, is machine learning with the Amazon Elasticsearch service. Now, our development team has been, investing a heavy amount of time into making sure that our customers get the features they're asking for. Among those has been anomaly detection with the Amazon Elasticsearch service. And what it does is it learns what's normal with your data. And it really doesn't require any prior machine learning knowledge. Now, once you've trained that model on the existing data that lives in the cluster, it's going to work real time on that time series data. And what it's going to do is use a random cut forest algorithm, and then it will detect those anomalies that normal, humans like myself or you can't really spot when you're looking across billions or millions of data points. So I just wanted to highlight this is one of the innovative features that we've come out with. But, without further ado, I really want to introduce, and I'm really excited to present, Seth and Kumar from the Capital One Idle Finance Group. They have a wonderful story to tell you. So, Seth, Kumar, it's all yours.
Thanks, Kevin. As you mentioned, I'm Seth Carroll, and I'm joined by my colleague Kumar Anand. We're both engineers from the Auto Finance Group at Capital One. And today we're going to be talking to you about how we're leveraging Elasticsearch in our log analytics pipeline for processing AWS logs. AWS logs are absolutely essential for understanding what's going on inside of your account, both from a cybersecurity perspective and also for operational monitoring. Like many customers, we started off with a simple approach. We turn on logging at the VPC with flow logs, and we turn on logging at each individual resource that we wanted to monitor. But this created a number of challenges for us. Based on the number of accounts we were supporting, it just didn't scale well, and it led to a lot of inconsistencies with our log configurations on the resources. Also, the native AWS log formats just don't provide a lot of context. And there were various log formats that humans were sitting to have to parse through and look at. And it just made it very inefficient to troubleshoot and diagnose issues in a timely manner. So we got together and we said, hey, let's identify some key requirements where we can build a better solution around this. Number one is that the logs need to be centralized, so we can go into one place and look at all the logs for all of our resource types for all of our accounts. And we also wanted to have those logs be enriched with extra metadata, so it'd be easy to search through. We wanted them also to be easily consumable through a UI and also through an API for some of the machine and tooling. The solution needed to scale as we added more and more accounts and many more resources. We wanted minimal upkeep. We also wanted the ability to be able to route alerts to individual app teams based on metadata on the log event. And of course, the whole thing needed to be HA and resilient. So the first question is, why do we choose to use the Amazon Elasticsearch service? Well, I can say from experience that hosting your own Elasticsearch cluster is not trivial. We did that in the past, and when we switched to the managed service, it removed a lot of the complexities and operational costs. We're able to scale the service to fit our needs. We've got some very large clusters, and we have some very small clusters. There's no external licensing at all. It's all done through the AWS bill, which for the way we operate is a big plus. There's also native integrations into other AWS services like SNS and S3 with UltraWarm. And Kibana also just makes it really easy for novice users to be able to go in and explore the data. So in this session, we're going to be talking about two different use cases for Elasticsearch. We'll talk about using it as a data store. This is where we're going to collect all the metadata, account information, resource tags, that sort of stuff. This is what we're going to be using to actually enrich the logs. The second use case is for log aggregation. And for the purpose of this session, we're going to be talking about AWS logs, but really the same approach could be applied to other log types as well. We'll start off with a high-level diagram, and so that you can get an overview and understand how things are connected, and then we'll dig in deeper into each component. We've organized the architecture into the following areas. We've got Cloud Custodian, which is responsible for the configuration of log sources, and it's also emitting metadata. We're collecting all that metadata and enriching it and making it available to our to Logstash. In our log aggregation, we're collecting all the logs from various sources and doing the enrichment and then making that available as an enriched data stream to StreamAlert. StreamAlert and Prometheus are used for alerting. We've got integrations with Slack and with PagerDuty. Our customers and consumers are both people and tooling that are accessing the metadata Elasticsearch as well as the log aggregation Elasticsearch. So we're using Cloud Custodian for two different purposes. Let's take a step back and let's talk about what is Cloud Custodian for those who may not be familiar with it. Well, Cloud Custodian is an open source, policy-driven cloud management platform that we use extensively at Capital One. It allows you to write YAML-based policy files that can make changes to resources in your accounts. For the purposes of this project, what we're using it for is to ensure that our resources have consistent logging configurations. Over on the right-hand side of the slide are some example policies, like for application load balancers and classic load balancers and S3 buckets. And essentially what these policies are saying is logging enabled? And if it's not, turn it on and make sure it's going to my standard logging bucket. The second use case for Custodian is a little bit different. In that previous example, those policies had actions associated with them, but it's also valid to run a policy without an action. Essentially what Custodian is doing is collecting all the information about the resource, similar to what you'd get from an AWS describe API call. There's some example policies on the right for the resources that we're collecting, and then you can see in most cases it's just 2 lines of YAML to collect the data. One difference too with versus the AWS describe call is that in many cases Cloud Custodian is going to be making multiple API calls behind the scenes to get a more holistic view of the resource. Once it's collected this information, it drops it down to our resources JSON file, and those get created per resource type, per account, per region, and we're collecting all those and we're putting them into an S3 bucket. That bucket is hooked up to fire off a Lambda when those get written. The Lambda function is really where a lot of the metadata processing happens. It's going through those records and parsing out the individual resource records and writing them into our Elasticsearch for data store. We organize that data store into a Elasticsearch index per resource type. So for example, one index for EC2 instances, and another for Omnis, and another for VPCs, and so on. We also do some enrichment. As we're processing the records, we'll look for certain key identifiers and do lookups. So for example, if we see a VPC ID, we can go to the VPC index and look up information about that VPC and get the name of it and put it right there on the record. Another example is AMI ID. If we see the AMI ID, we can go to the images index and look up, what's the name of this AMI? When was it created? What OS type? Things like that, and then store those back into the original record as well. Another interesting challenge was ENIs, or Elastic Network Interfaces. ENIs are typically not tagged in your account, and that's because they're generated dynamically by other AWS services. And so the way we worked around that is that as we're processing ENI records, we can determine which resource that ENI is attached to, and then we can go query our data store to figure out what tags are on that resource. Then we can take the tags from the ENI, or from the resource, and apply them onto the ENI record. Finally, we apply a last seen timestamp, and that's just so that we can identify inactive records in the database. So at this point, we've got this really great set of metadata. It's essentially metadata that's been enriched with more metadata for a large set of resources across all of our accounts and regions. And this has enabled us to build other tools and dashboards with this data set. One example of that is a Chrome plugin that we wrote that allows you to search on a AWS identifier. So for example, we get these EC2 instance retirement emails, and you could highlight the EC2 identifier in the email and look it up and pull the data from our data store through this web browser. In this case, we keep the inactive records as well, so we can see this EC2 is already gone, it's gone inactive. Here's the last timestamp that we saw this resource, and here's all the information that was on it before it went away. Really handy for troubleshooting something. So now we need to take this metadata and also expose it so that we can use it for log enrichment. We chose to write an API in front of the Elasticsearch API that's able to do a bulk query and do the data transformations that are required to make it in the format that Logstash is expecting. We do this, that format is to have a JSON object with a top-level key as the piece of data you match on, and then the key value pairs inside that object are the fields that you want to enrich into the log. And we do this for IP addresses, ENI identifiers, and load balancer ARNs. The API returns the large JSON response for all the active records in the database. And we do this for all the accounts in one so that you can identify multiple endpoints within the same record that go cross-account. And so on Logstash, we're fetching this enrichment JSON information from that enrichment API on a set cadence. And we're using the Translate plugin, which is a plugin that lets you key off of a field in your log document and do a lookup into a dictionary. And so in our case, that dictionary is our enrichment JSON that we pulled down from the API. And we can match on that field and then take the enrichment fields and put them into the log document itself. And so for an example on ELB access logs, we would do this on the ELB itself. We're able to look at different pieces of information in the log and build the ARN of the load balancer and then match it into the load balancer enrichment data and get all the tags off the ELB and put them in the log document. Same thing for the client that's accessing the ELB. Get all the tags and information for that. Also for the EC2 that's serving up the request on the ELB. Get all the tags and information there as well. We have a similar approach for VPC flow logs for the source and destination, and also for clients that are accessing S3 buckets. So we'll take a look at an example here of a user that's searching through ELB access logs, and they're searching for logs that have a component tag on the ELB with a value of web app. And they're specifically interested in the ones that were served up by an EC2 that had the name of web node 1. And they're looking at some of the 500 errors. And again, this is the customer is looking at this through the terms and the tags that they're familiar with. So it makes it really easy for them to search through these logs. Another example that we use frequently is troubleshooting security groups and looking again at by application, by environment tag, and so on. Really easy to look through flow logs that way. We also have a process at Capital One where we frequently will analyze cross-region traffic patterns and categorize it by application so we can see dependencies between applications. So let's take a look at the log aggregation architecture itself. We have the requirement to have an active-active two-region solution so that if we lost monitoring in one region, we still had access to all the logs in the other region. So on this diagram, we'll start at the bottom and work our way up. We've got our standard logging buckets where all the logs are being delivered to. Each log bucket has an SNS topic associated with it for the create object events. Each SNS topic has two SQSQs subscribed to it. That's for the west consumption and the east consumption. This is how we're getting our duplicate data to east and west, two copies of it. Each Logstash node is using the S3 SQS plugin, which is a plugin that lets you read messages from an SQS queue and then go fetch the actual log objects from the bucket and do the processing. One benefit of that approach is that it lets each Logstash node operate completely independently of each other, and that we can scale up and scale down this ASG as needed. We also get to run it on spot instances, which is nice because it saves us a little bit of money. As we talked about previously, all the enrichment is happening within that Logstash pipeline, and that enriched output pipeline feed is essentially sent to two different output sources, or destinations, excuse me. One of which is the log aggregation Elasticsearch cluster, and the other is a Kinesis data stream. That Kinesis data stream is what is going to be used for StreamAlert, and Kumar is going to tell you more about that right now. Kumar, I'll hand it over to you.
So thanks, Seth. This is Kumar from Capital One. I'm going to talk about StreamAlert, which is our alerting solution. As Seth talked about Elasticsearch, which we are storing all the logs from various sources to do our troubleshooting. And now question is, how do we solve our detection? And that's where we started using StreamAlert, which is open source from Airbnb. And we just modified a little bit to make it work for Capital One. Now question is, why do we need StreamAlert? So it's of course it has a various good features. It's a serverless. We don't have to worry about rehydration. We don't have to worry about patches. Deployment is easier. It's scalable, where we are using Amazon Kinesis to get all the log events, and that can scale pretty fast, and that's where it's scalable. It does have an infrastructure as code, where we are writing code in Terraform, so we can build infrastructure from source, and we can take that code to any AWS environment, and we can build that infrastructure. It's secure. We are using TLS, we are using KMS keys, we are using least privilege IAM role to make sure that it's secure. And at the same time, it provides real-time alerting. It does have extensive data format support, where we can have JSON, we can have CSV, we can use key value pair, various type of log sources, and that's why it helps us a lot. So let's talk about the architecture. So if you can see, Seth talked about we are getting all the logs in Logstash, and then we are sending to Elasticsearch. So when we get to Logstash and we enrich it, and we are sending the same log to Amazon Kinesis. And Kinesis comes very handy. We get all the events. It can scale pretty fast. And once we get those events from various log sources in Kinesis, we are firing classifier Lambda, which looks into those events, match with the existing schema defined, and if it is good, we are sending those events to SQS queue, and that SQS queue fires rule engine, where it get evaluated across multiple rules which we have written to fire alerts. So various rules are already there from the community, and we have written our own rules in Capital One, and once any of those rules match with the log event, we are sending those logs and storing temporarily into Dynamo. And once we store in Dynamo, it's a temporary persistence, where our alert dispatcher Lambda looks into those Dynamo alerts every minute and see if those alert needs to be merged, or those alert needs to be route to the application team. So for routing those alerts, we are using Prometheus Alert Manager, where all those alerts get routed to multiple teams based on the application key value. And we'll talk more about it, why we are using Alert Manager. But for now, this is our current flow, where once it routes to our notification system, which is a PagerDuty, and then we do use Slack for notification. Now let's talk about the historical search. Why do we need historical search, as we already have that data in Elasticsearch? So we'll talk about that more, like how much data we are storing in Elasticsearch, but goal here is to have those logs for longer term, maybe for a year, maybe for 5 years. So once we have those logs in Athena, we can either do historical trend analysis, we can do some kind of reporting, we can do visualization on top of Athena, we can even do some kind of modeling based on the data what we have. So let's see the architecture of it. So once we get those events into classifier Lambda, it fires Amazon Firehose, which is backed by S3. Once that data comes to S3, we push the event to SQS, and we have partition Lambda, which collects those metadata and put into Athena, and we are using Athena to query those historical data. So that's the overall architecture we have. So let's talk about a Prometheus alert manager, why do we need it? So of course we wanted a solution for intelligent alert logging, and we are in YBYO model where you build it, you own it. Teams owns their own application. They are responsible for operations. Enriched log allow to dispatch alerts based on the metadata, because if you have one alert and you have hundreds of system, and we don't want to write hundreds of alerts. So we have one alert based on the metadata. We want to route those alerts to the right team, and that's where Prometheus Alert Manager helps us a lot. So you can see that automatic routing of respective application team happens based on the key value of the metadata, and that works well for us. Let's talk about some of the logs type and how we are leveraging those rules from those logs. So one of the log type we have is access log, which is coming out of ELB, ALB, or even WAF, even it is CloudFront, various logs. So AWS have those access logs. We are pushing to S3, and then of course when it comes to Elasticsearch, before it hits the Kinesis, we are trying to do some kind of rules on top of that. So one of the rule which we wrote is if somebody calls from headless Chrome outside some of the particular subnet range, then we want to detect it. And why do we want to do that? So of course we want to detect some kind of DDoS situation on our ELB, where somebody is trying to do curl and DDoS the application, or somebody want to do web scrape and DDoS the application. So we just want to avoid that, and we want to detect that as soon as possible, and that's where this alert comes handy. So we do have many more alerts based on those access logs, like if you have particular status code coming, or if you are getting events from some of the specific country code which we want to filter out. All those kind of things we can detect here, and we can alert on it. So let's talk about other log types. So VPC flow log. This is one of the wonderful log where we are getting all the network layer traffic, and we wanted to detect if, let's say, application A calls application B, and we don't want any third application calling application B. We can detect it through a VPC flow log, and of course, enrichment helps a lot here. So that's where VPC flow log helps. We do have many more examples, like if you want to see some particular location, we are getting rejects, or some kind of spike in reject traffic from either one location, or overall as application we are getting that. So, or some kind of we are getting call from some particular IP which you don't want. So those kind of things we can detect through it, and we are trying to detect those problems through VPC flow log using StreamAlert. Next one is CloudTrail. So CloudTrail comes very handy for our troubleshooting. So far, we are using that for our reactive incident management, where something happens, we go and check, oh, who did that, what time it was done, or what kind of things going on in our events. But now with this solution, we can proactively detect some of the problems where we wanted to take action. So for example, if somebody is using a destructive API call, somebody is going and deleting flow log, somebody is deleting subnet, those kind of events we want to alert right away. And that's where this StreamAlert comes handy, where it detects those events and fires alerts, and we take action accordingly. We do have many more examples of CloudTrail. We do have from community as well as we wrote our own. For example, somebody's got the access of our root key. We want to detect that. If somebody is making some of the resource public, or somebody is trying to kind of access our database snapshot, those kind of things we wanted to detect, and CloudTrail helps a lot there. So it's a very handy and very useful events. So now, how do we monitor our Elasticsearch? So of course, Elasticsearch helps with our monitoring. StreamAlert helps with the monitoring, but we have to make sure that our Elasticsearch is up all the time for our troubleshooting. Whenever there is an incident, we should be able to troubleshoot the problem. And that's where we are using Prometheus. Prometheus we use for our infrastructure monitoring, which is open source, and it does helps with the Elasticsearch monitoring. We are pulling all those metrics, and you can see the visualization, and we have written a lot of alerts on top of that to making sure our cluster is green. It has enough space to serve the intent, or kind of it is always up, those kind of things. So it helps with the monitoring. Next is UltraWarm, so which is a wonderful feature I mentioned maybe Q4 last year, early this year, where it helps a lot with our increasing our retention and reducing the cost. So you can see that we were having only 10 to 14 days of logs in Elasticsearch, and once UltraWarm came, we started storing logs for 90 days. And you can see that with 90 days log, with the same data, we are saving 20% of the cost with respect to 10 to 14 days of log in Elasticsearch. So that's a great saving and great feature where we are able to extend our logs for 3 months, where you can do more analysis, more trend troubleshooting, all those kind of things with this. It does helps with our index state management, rollover indices, transition from hot to warm. It's pretty easy. So it's a great feature Amazon launched, and thanks AWS for that. Next benefits. So it's a near real-time search. It helps with the troubleshooting. Now we are able to analyze billions of records in few seconds. It provides aggregation to explore trends and patterns of the data. Enriched log messages make searching much easier for users. So if in the past we are not having enriched log, where it was difficult to know from which application where it is coming, what are the related metadata for that, and with this enrichment, it helps us a lot. Of course, UltraWarm helps a lot. It expands our retention period, and overall, it gives us a consolidated view across AWS accounts. What is next? So anomaly detection. So it's a built-in feature in Amazon Elasticsearch. We are already using this in our non-prod to solve some of our rejects spike or some of the status code spike, and this comes very handy when there are some scenarios where we cannot do monitoring with traditional alerts. So that's a great feature. So that's all I have. Thank you, and thanks for watching. I hope you enjoyed the video. Thank you.